Good morning students, this is Chandravati. Welcome to paper 4 Natural Products class. Natural products are the compounds which isolated from different natural sources such as plants, animals, microbes, insects, pathogens and marine. These are known as secondary metabolites because they are formed due to the enzymatic reaction of primary metabolites like amino acids, vitamins. Simply, natural products are the compounds which occur in nature. In paper 4, the second unit is terpenoids. From this class onwards, you are learning about terpenoids. Is the term which occurs from terpentoyl. In this class, you are learning about introduction of terpenoids, isoprene rule, and classification of terpenoids. Introduction. Terpenoids are secondary metabolisms synthesized in plants and animals, especially in marine animals. Terpenoids are occurred in fruits, flowers, leaves, stem, bark of the plant, and marine organisms and fungi also. Terpenoids are occurred from fruits, flowers, leaves, stem, bark of the plant. That means all parts of the plant contains terpenoids. All terpenoids undergo thermal decomposition to give isoprene units. This means when terpenoids are heated, these are decomposed to form isoprene unit. So, the terpenoids are the compounds which contains isoprene units. Physical properties of terpenoids. Terpenoids are colorless liquids. These are soluble in organic solvents but insoluble in water. Most of the terpenoids are optically active. They are volatile in nature. The boiling point of terpenoids lies in between 150 to 180 degrees centigrade. Chemical properties of terpenoids. Terpenoids are unsaturated compounds. These are contains double bonds. So, they undergo addition reactions with hydrogen, halogen and halogen acids. Terpenoids undergo polymerization reactions and dehydrogenation in the ring to form aromatic compounds. All terpenoids on thermal decomposition forms isoprene as one of the product. All the terpenoids on thermal decomposition forms isoprene as one of the product. This means the terpenoids contains number of isoprene units. Isoprene. Molecular formula of isoprene is C5H8. C5H8. This is the structure of isoprene. Isoprene is the general name. The IUPAC name for isoprene is 2-methyl 1,3-butadiene. 2-methyl 1,3-butadiene. So, on thermal decomposition, terpenoids forms these isoprene units. Basing on this, in 1887, Wallach proposed the isoprene rule. In 1887, Wallach proposed the isoprene rule. It states that the skeleton structure of all terpenoids are built up of isoprene units. So, the terpenoids are formed by the combination of isoprene units. This is known as isoprene rule. Next one is special isoprene rule. Terpenoids are formed by the combination of isoprene units. But how they are combined? The special isoprene rule tells this. This rule is proposed by Ingold in 1925. According to this rule, the isoprene units in the terpenoids are joined by head to tail linkage or 1,4 linkage. In isoprene unit, the end in which the methyl group is substituted, it is said to be head and the other end is said to be tail. In the numbering form, the first carbon is said to be head and the fourth carbon is said to be tail. So, the first carbon of the isoprene unit is attached to the fourth carbon of the another isoprene unit. So, this is the head of the one isoprene unit and this is the tail of another isoprene unit. So, this is said to be head to tail linkage or 1,4 linkage. In most of the terpenoids, there is an 1,4 linkage or head to tail linkage. In isoprene structure, except methyl group, remaining 4 carbons are in sp2 hybridization. So, the structure of combined isoprene is like this. In this is the head and this is the tail. So, this is the head and this is the tail. So, all isoprene units are combined like this to form terpenoids. The next topic is classification of terpenoids. The terpenoids have general formula C5H8N because they are formed by the combination of isoprene units. Based on the number of isoprene units in the terpenoid, they are classified into several types. The following table shows the types of terpenoids. Here, value of N indicates number of isoprene units. If N is equal to 1, that means if the terpenoid contains only one isoprene unit, it contains 5 carbon atoms, then it is said to be hemiterpenoid or simply isoprene. If the terpenoid contains 2 isoprene units, then it contains 10 carbon atoms. It is said to be monoterpenoid. Remember that monoterpenoid means it contains 2 isoprene units. Similarly, if the terpenoid contains 3 isoprene units, then it is said to be sesquiterpenoid. And if the terpenoid contains 4 isoprene units, then it is said to be diterpenoid. If terpenoid contains 5 isoprene units, then it contains 25 carbon atoms and it is known as sister terpenoid. And if terpenoid contains 6 isoprene units, it can have 30 carbon atoms. So, it is said to be triterpenoid. If the terpenoid contains 8 isoprene units, then it contains 40 carbon atoms and it is said to be tetraterpenoid. The molecular formula of tetraterpenoid is C40H6. If the terpenoid contains more than 8 isoprene units, that means it have more than 40 carbon atoms, then it is said to be polyterpenoid. So, basing on the number of isoprene units in terpenoid, they are classified into hemiterpenoid, monoterpenoid, sesquiterpenoid, diterpenoid, sesquiterpenoid, triterpenoid, tetraterpenoid and polyterpenoid. Terpenoids are also classified basing on the number of rings present in the structure. They are acyclic terpenoids, monocyclic terpenoids, bicyclic terpenoids, tricyclic terpenoids and tetracyclic terpenoids. If the terpenoid contains open chain structure, then it is said to be acyclic terpenoid. If the terpenoid contains only one ring in the structure, then it is said to be monocyclic terpenoid. If the terpenoid contains two rings in the structure, then it is said to be bicyclic terpenoid. If the terpenoid contains 3 rings in the structure, then it is said to be tricyclic terpenoid. Similarly, if the terpenoid contains 4 rings in the structure, then it is said to be tetracyclic terpenoid. The general molecular formula of acyclic terpenoid is CnH2n plus 2. It is similar to that of alkanes. And the general formula of monocyclic terpenoid is CnH2n. It is similar to that of alkene. And the general molecular formula of bicyclic terpenoid is CnH2n minus 2 and it belongs to the molecular formula of alkyne. And the molecular formula of tricyclic terpenoid is CnH2n minus 4 and tetracyclic terpenoid molecular formula is CnH2n minus 6. By using these molecular formulas, we can identify the number of rings in the terpenoid. So, by using the general formula, we can identify the rings in the terpenoid. So, this is about terpenoids introduction, isoprene rule and classification. Now, you write an assignment on this class.